There are often cases when developing a hexahedral mesh on a complex geometry where the default sweeping method selected by Cubit may not be successful. Cubit provides a few tools that can provide some additional information to the sweeping algorithm to aid it in generating a successful mesh. The tool we'll look at today in this brief tutorial is called vertex types. Let's look at an initial example where Cubit can automatically set vertex types. If you're following along with the provided example files, open the file named example19_1.cub. As you can see, this is a simple L-shaped block, which Cubit really has no problem meshing. So let's go ahead and do that using the default meshing scheme. This is indeed exactly what we'd expect. However, let's change things up a little bit by first deleting the mesh and then modifying our source and target for this model. To modify the source and target, let's go to the command panel window. We can locate it by going to Mode Mesh, Entity Volume, and Action Mesh. We first select our volume as the entity to mesh, and then go to the drop-down widget and select Sweep as the meshing scheme. From this panel, we can manually select our source and target. For this example, let's select surface 17 as our source and surface 12 as our target. We can then apply the scheme and then mesh. We can see a dramatic difference in the mesh we've generated just by changing the source and target. One of the things we also notice when we examine one of our side surfaces is the number of quads immediately adjacent each of its vertices. At these vertices we see a single quad, however at these vertices we see two. Looking back at Cubit's default mesh for this model, the number of adjacent quads to each vertex is indeed different. The number of quads at a vertex for a given surface is what characterizes a vertex type. Cubit recognizes four different kinds of vertex types: the end, side, corner, and reversal, corresponding to 1, 2, 3, and 4 adjacent quads respectively. Cubit normally sets vertex types automatically based on the approximate angle at the vertex. Cubit also provides a tool for manually setting the vertex types. We'll explore that tool later in this tutorial. Let's look now at how we can display the vertex types that are currently set for any given surface. To do so, we can use the Draw Surface command, adding the words vertex type as a qualifier. Notice here that it draws the surface by itself along with labels for each of its vertices. The number represents the unique vertex ID, while the letter represents one of the four vertex types: end, side, corner, or reversal. Let's look at an example now of how setting vertex types can help us mesh a difficult model. To begin with, we can use the File New menu option to begin a new session. Once again, if you're following along with the example files, you can open example19_2.cub. Let's take a look now at what makes this small model particularly difficult to mesh. Normally, for a model such as this, we look for natural sweep directions. For example, sweeping radially from this surface to this surface, or from side to side along this path. The problem arises because of these two circular imprints. Although there may be several different solutions for this problem, for purposes of this example, we are going to treat this model as if it was an L-shaped block, where the bottom of the L is this surface and the back of the L is this surface. We'll attempt to do a many-to-one sweep using these surfaces as sources and this surface as the target. Let's begin preparing our model for meshing by setting some sizes on our key features. To set a size on the larger circular surface, first select it, and then we can set the size in the Properties page. Scroll down to the requested size and enter a value of 0.05. Do the same for the smaller surface, but enter a value of 0.03. Let's now go ahead and set up our source and targets for sweeping. As you can see here, we already have our sweeping panel open, but just as a reminder, you can open the sweeping panel by going to Mode Mesh, Entity Volume, and Action Mesh. Let's select the volume for our pick widget and then select Sweep from the drop-down. In the field labeled Source Surface IDs, we'll want to enter 4 surfaces. You'll want to hold down the Control or Command keys to do a multi-selection. To enter the target surface ID, rotate the model and then select the bottom surface. Now let's see what happens when we hit the Apply Scheme button. Although the sweep scheme was applied successfully, pay attention to the warnings that appear on the output window. These indicate that Cubit was unable to successfully assign vertex types. Just to see what happens, let's go ahead and try meshing. At first glance, it looks like the mesh was successful, but once again, if we pay attention to the output window, we'll see several errors reported. Now, examining this case a little further, we recall that our initial intent was to treat this as an L-shaped block. If you remember from our first example in this tutorial, which actually was an L-shaped block, we would want to match the same vertex types for our current problem. If we look at our side linking surface, we notice that Cubit assigned these vertices as sides, although the other vertices are correct. So in order to get the mesh we really want, we'll need to let Cubit know how to define the vertex types at these vertices. Before we do that, let's first delete the mesh that was initially generated. And then we'll use the command panel for assigning vertex types. In the command panel window, select the Mode Mesh, Entity Surface, and Action Mesh. Since vertex types are always assigned with respect to a surface, we first choose the surface that we're going to work on. In the command panels, the submap surface meshing scheme is where we can set surface vertex types. So choose the drop-down widget and select the submap scheme. Clicking on the Advanced checkbox will reveal the fields for setting surface vertex types. Before we do that, however, let's use the command we learned previously to draw the current settings for vertex types. In the command line window, I'll go ahead and type the command to display Surface 25's vertex types. This shows us that we'll want to change the vertex type assignments for vertices 34 and 32. We'll display the volume again. In the command panel, enter the surface ID in the pick widget, and then select the vertices that are associated with end vertex types. Since the only other type we have for this surface is a corner, let's jump down to the corner field and we'll select its vertex type. Hitting the Apply button now will set these vertex types, but also display their settings in the graphics window. I'm satisfied with those settings now, so I'll go ahead and apply the scheme to the surface. Our part isn't quite ready to mesh yet. We'll first need to apply the vertex types to the opposite surface as well. I'll go through the same steps I did for this surface as for the opposite surface. First, we'll make sure we're in the right place in the command panel, and then select the surface where we'll be setting the scheme. Once again, drawing the vertex types for this surface, we notice that vertices 31 and 33 need to be changed. So let's go ahead and select the vertices as we did on the previous surface. First, the vertices with an end vertex type, and then the one vertex with a corner vertex type. And once again, hitting the Apply button will update the vertex type settings. Before going on to mesh this, I just wanted to point out one thing. Take a look at the journaled commands in the output window. Although it took us a while to walk through the procedure using the GUI, for most complex meshing problems, you'll most likely be using a journal file. Copying and pasting these commands into your journal file or editing your journal file directly is usually the most efficient way to set vertex types, rather than using the GUI. Okay, so let's apply the scheme, and now we should be ready for meshing. First I'll redisplay the model, and then I'll use the context menu to go ahead and mesh it. So looking at our output window, I didn't see any errors reported, so that appears to be a good sign. You will want to be careful of mesh quality issues when you're modifying vertex types. For instance, at this location, we have an angle of close to 180 degrees. We'll look at other ways to deal with issues such as this in later tutorials, but for now we'll claim success on this particular model. I hope you've enjoyed this tutorial on setting vertex types in Cubit. Thanks for watching.